Hello, this is Shinru. In this video, we are going to take a look at question 337, House Robber 3. So in this question, there's a thief has found himself a new place for his thievery again, and there's only one entrance to this area, it's a route. So the thief will go through from the route and basically the thief can only go to another node that's not next to the current node, because it will automatically contact the police if two directly linked houses were broken into on the same night. So as you can see in example 1, so the thief can either only go through 3, 3, 1, or the thief can only go through 2 and 3. Because 3 is the entrance, so the thief, because the root area is the entrance, but the thief doesn't have to necessarily to rob the entrance. Therefore, the thief can either go to 3, 3, 1 or 2, 3. But because 3, 3, 1 is 3 plus 3 plus 1 is 7, and 2, 3 is 5, therefore we to get the maximum amount of the money, so the thief has to go through 3, 3, 1 in example 1. And in example 2, the thief can go through multiple positions. So for example, it's 4 and 5 or 3, 1, 3, 1. So if the thief goes through 4 and 5, it will collect $9. And if the thief go through 3, 1, 3, 1, will collect $8. Therefore, we choose 4 and 5. So looking to this question, there are two patterns we can get. So first pattern is the thief can only only go through nodes by jumping different nodes. So for example, so the thief can only jump one node to go to another node. So the thief cannot go to a directly linked node. So here, so that's the first thing we know. And the second thing we need to know is the thief has two possibility when he or she enters the tree. So first possibility is go through the root node, so it's 3, and the second possibility is go through the left node and the right node of the root node. So based on the two entry points, the thief can only collect two possibilities. So there are only two possibilities the thief can go through all those houses, because the rule is that the thief cannot rob a directly linked house. Therefore, based on what node the thief goes into, we can get the sum. So based on these two patterns, we can find out that that the thief can go through two patterns, and we have to visit all those nodes, and we can make every nodes our current node, and the thief will have to go through the exact same way to those nodes. So now let's get into coding. It's quite difficult to explain. So basically, we first choose, should we use an iteration through the tree, or should we use recursive function through the tree? So the answer is recursive function, because the thief has to do a depth first search based on the entry point, and the recursive function is easy to implement this kind of operations. So okay, so basically we can make this rob a recursive function. So another question is that do we need a variable defined outside of this recursive function? So the answer is no, because there are no other possibilities. So we don't need to update of a variable outside of the recursive function. This question has a finite solution, and in this case, I think there are only two possibilities. Therefore, we can just run a maximum value in our recursive function instead of updates of a value constantly. So now we decide we can write only one recursive function, and therefore we can make our rob function a recursive one. So in this case, so the rob function will accept a root node. So if the root node doesn't exist, we will return 0. Because when the root node doesn't exist, there's nothing to rob, therefore we return 0. And because we are making it a recursive function, so the root node, we can also view it as the current node. If the current node doesn't exist, then there won't be more money we can rob, and based on the non-existing current node. So now we get the left value and the right value we can rob so basically, okay, so let's make it more easy to understand. So for example, there are two possibilities a thief can enter the tree. So in possibility 1, so if the thief gets into the tree based on the root node, then what we need to do is, what we can know is the thief will never go through the left node and the right node of the root node, but the thief will go through all the subnodes of the left node and the right node. Therefore, when we know this rule, so if we go through the root, so first case, if we go through the root, so the money the thief can collect first is the money in the root node, therefore root.value. And then based on the condition, if root.left exists, then the value should add, we will rob the value on root.left.left, and we will rob the value on root.left.right. Because we will never rob the value for left node and the right node of the root. Therefore, we will jump one node and only rob the place of the left node and the right node of the left node of the root node, if left node exists. And the same goes with the right node. Okay, so after we get this, so the value 1 will be the possibility sum that the thief goes into the tree from the root node. And possibility 2 is the thief goes through the tree from the left node and the right node of the root node. So we can do the same. In that case, what we need to do is the value 2 will be, we will just rob the left node of the root node and the right node of the root node, and we will add them all together. So this will be our value 2. So what we need to do next is just to return the maximum value of the value 1 and value 2. So let's submit the solution. So basically in this question, why we need to make the rob function a recursive function is because we find out the similar pattern when we find out the similar pattern to do with other node as the root node. For example, if we try to go through this tree in example 1 using our function. So first we will go through the root node, and we find the root node, and then what we will do is define the value 1. So the value 1 will be 3. So the value 1 will be 3, and then it will start checking if the left node or right node exists. So if the left node exists, so it existing, and then we will start looking for the left node of the left node which doesn't exist, therefore it returns 0, and the right node of the left node exists, therefore returns 3. Therefore we have 3, so we add this 3, and the same goes with the right node. So we can only find the right node of the right node exists, therefore we plus 1. And the second case we will do the same. So, and it is the same as we start from node 2. So it will be the same procedure. We will also check there are 2 possibilities, and we will also check those 2 possibilities to get our value. So this is basically how we use this method, where we use the recursive function, because we need to do a depth first search we need to visit every left node and the right node for every current node, and we need to, based on the current node, we need to add those current node into our value 1 and value 2, then we compare them.